Now we're going to be taking a look at how to classify different types of chemical reactions. There are some basic rules, and there's only 5 types of reactions we're going to be looking for. So let's just take a look at some examples. Now, the first example is what we call single replacement, or sometimes called single displacement. You can always identify these because you have one single element plus a compound. So it's one small thing plus one larger thing. What's going to happen and what you need to look at is, okay, what are the traits of this single element? This is a cation, which means that it has a positive charge. In fact, magnesium has a positive 2 charge. What it will do is it will displace or replace something of the similar type of charge. So since this is a cation, it will replace the other cation within the compound. Zinc is the cation. It is a +2 charge, so it has a plus charge as well. What's going to happen is it's going to replace that similar charge because it has a higher affinity towards chlorine. Essentially, it has a stronger attraction force, and it will kick out zinc. So we see basically just kicking out those, and that's all that's going on. Now in this case, we see bromide, or bromine gas. Now bromine, when it becomes an ion, will become a negative charge. In fact, it's a -1 charge. It will replace the other negatively charged ion. This is an anion. It will kick out the anion of this compound. And we don't find this a whole lot, but you do need to keep in mind, just keep your wits about you as you're looking at these equations, because ultimately you're not going to know what these products are going to be. You're just going to see bromine gas plus silver iodide. So it's going to replace the like type of charge, so it's an anion. It will kick out the other anion, and that's why we see silver bromide being formed. Now, the next type of reaction that we're going to see is double replacement. Double replacement is simply 2 replacements going on. Here I see 2 compounds. I see silver nitrate and I see sulfuric acid. And you can think of it 2 ways. You can think of it as the anion replacing the anion or the cation replacing the cation. It doesn't matter how you want to think of it, but essentially it's easier for most people to think of it as just these 2 are going to take places. Again, the reason is hydrogen has a higher affinity for nitrate than it would for sulfate. Sometimes we want to anthropomorphize this, and we want to say that hydrogen likes nitrate better than silver, so it will kick it out, and then silver will take its place. So however you want to think about it in this chapter is fine. We just have to look at it as swapping partners with this because of that affinity. Now here I would see sodium and hydrogen would take place. Now look at, this is an interesting teaching point as well. Sodium is going to take the place of hydrogen. Now we don't leave this as hydrogen hydroxide, although sometimes it certainly behaves that way. We're not going to leave it as, in terms of products, as hydrogen hydroxide and sodium chloride. You need to think outside of the problem just a little bit more and realize that hydrogen hydroxide is in fact water, which we write as H2O. That's a double replacement. Now, synthesis or combination, I don't care which way you want to think of it, essentially is 2 small things making one big thing. So we see potassium plus chloride. Now, a lot of times students are going to want to keep this 2 and turn it into like a math problem. So you're going to want to do potassium plus chloride, and you're going to want to make KCl2. Now remember, when these elements get together, we have to consider their charges. When potassium gets ionized, it forms a +1 charge. When chloride becomes ionized, it has a -1 charge. It's just a 2 here because it's by itself, it's diatomic. But when it gets together with potassium, it doesn't. So we just write it as KCl, not KCl2. Don't fall into that trap. That's a very common mistake. Here we see another example of the diatomic, and some mistakes that can happen there is we just write SO2, and that's sulfur dioxide, when in fact we need to consider charges. Sulfur will make a +3 charge, and oxygen will make a -2. I would probably, in this one, I would give you what that product would end up being, and you just classify this as a synthesis. That's going to be a tough one for you to find what its product would be. Now here we need to also be careful. Nitrogen plus hydrogen. We typically see nitrogen as something like calcium nitride or something like that. Well, when nitrogen gets together with hydrogen, both of them are ionized. Both of them are are diatomic, when they get ionized, sodium or nitrogen ends up with a +3 charge, and hydrogen ends up with a -1. Another combination, and you guys don't have the skills to know this, another combination would be possibly that hydrogen would have a +1, and then hydrogen would have a -3. So you really have to be careful of what is going on. In this case, if the product of ammonia was given to you, you know that nitrogen was a positive charge. Nitrogen acts like a cation in this case. If you're just predicting what the products are going to be, well, then you could write ammonia, or you could write hydronitric acid and balance it that way. So just be careful. It depends on what you're given. If I'm just giving you reactants and you have to predict the product, you know that it's a synthesis, and that's about it. Now, the opposite of that is going to be a decomposition. Now, there are some rules for what it's going to decompose into, but essentially it means one compound into many smaller compounds or simple elements. So another example, we have sodium plus bromine. Now here we have to, again, be careful. It's diatomic, so be looking for those along the way. Now, combustion reactions. Sometimes these are buggers to balance. So it's important to know what that is. If it's incomplete, it's going to make a carbon monoxide. If it's complete, it's carbon dioxide. Now, don't think too much. When you know that and recognize that it's combination or combustion, you know that it's going to be something plus oxygen, because nothing combusts without oxygen. It's going to decompose into either carbon monoxide or carbon dioxide plus water. That's it. So keep it simple. All you have to do is plug in what that compound is. In this case, with C6H12O6, hey, biology people are flipping because we should be seeing this. This is cellular respiration, people. C6H12O6 plus O2 yields carbon dioxide because it's completely combusting CO2 plus H2O. How cool is that? Now we have an internal combustion engine within every single one of our cells. Yeah, I'm a geek. It's okay. So basically, we balance from there, and just kind of go through your rules. Okay. So there's your product as we go. Now, ethane. Okay, I would give you this compound. Later on, you're going to get the skills of how to write ethane. Maybe you have them already. It incompletely combusts. What that means is we're going to use carbon monoxide this time. So I just plug in those numbers: C2H6 plus. Now we go back to our template. O2 yields carbon monoxide now, plus water. Sometimes these get to be buggers and balancing, so just be patient with it. Sometimes you have to erase and things like that. You'll be all right. Just keep going. Okay? This one was actually not too bad to balance. You probably get that one okay.